We are Team Elektro 8754, and this is our third year competing in the First Tech Challenge. Our process is simple. Once we discuss our ideas and do rough drawings, we work together by harnessing our strengths and defining our roles: programmer, designer, builders, then prototype and test. We kickstarted the season by participating in TechGarage's 30-hour FTC kickoff event, where we strategized, designed, and built a robot in less than 30 hours. We focused on building an intake and shooter so we could put balls in the center vortex, but after the event, we decided to revise our strategy. Our strategy is a strong autonomous program, push the colored beacons, and finally to pick up the cat ball. We use color and gyro sensors for a more accurate autonomous. Our autonomous program scored 90 points during our first tournament, 30 points for shooting 2 preloaded balls, 15 points each, and 30 points per beacon. We hit 2 beacons for 60 points. One of our goals was to beat the current world record at our first tournament, 140 points. We didn't beat it, but we came close, scoring 119 points. Our strategy was to push the beacons 10 points each and make sure the cat ball is off the ground during the end game. We like to use Autodesk Inventor to CAD our robot. The base is composed of Acrobotics channels measuring 12 and 16 inches in length. It is a 2-motor drive system that connects to 4 wheels with 2 wheels per motor. This allows us to utilize a tank drive system that effectively makes our robot drive like a tank, using 2 joysticks, one for each side of the robot. The main goal of this chassis is to keep it as simple as possible so it makes for easy repairs and isn't high maintenance. We laser cut parts for a sleek look. For the next tournament, our goal is to lift up the cat ball high and drop it in the center vortex. Our initial idea was to use rev channels that slid on linear bearings. After testing, we realized that the bearings created an unsmooth linear motion. Drawer slides were a viable option because of the bearings and the simplicity of bolting them together, creating a smooth cascading lift. We communicate via email, group text, and do our notebook notes in Google Docs. We have regular meeting times 3 days a week, but typically spend on average more than 5 days and over 15 hours a week on our robot. We are passionate about educating people about first and robots. Last summer, 2 of our team members introduced the first ever robotics program to a local school summer camp and taught 4th and 5th graders basic building and programming. We volunteer and work at our Tech Garage summer camp, where we teach others about robots while also funding our team and organization. We enjoy working with our community of teams at Tech Garage. As senior members of our organization, we like to help other teams build, program, and have fun.